Good day, ladies and gentlemen. Welcome to Risk Management 1.1, Chapter 2, Characteristics of Hazards. Very, very important. From Chapter 1, ladies and gentlemen, we have seen that we've looked at a lot of theories from different learned people. And then what we have done from those theories, we have deducted that we're going to take one definition forth, which explains what hazards are. And we said hazards are anything that can cause harm that has certain characteristics. Now, Chapter 2 starts from the second part of the definition, which has characteristics. We have established the first part of our definition is anything that can cause harm, and it echoes from all the theories of the learned people that we've seen in Chapter 1. All right, let's look at the second part, which is all hazards have got certain characteristics. What are those characteristics? They're in front of us. Any hazards consist of matter. Also, hazards are governed by natural laws. They have symmetry, meaning balance or proportion. They have weight. They have volume and size. They have density. They have shape. They have texture or surface. They have energy. And they can interact or interface. And they pose safety risk and can create safety risk level. Let's look at the first characteristic. Matter is the substance which all physical objects are composed of. Definition, very key. A substance that occupies space is composed of atoms or atoms, and atoms are made of protons, neutrons, as well as electrons. It has mass and is the term that traditionally refers to the substance of which all bodies consist. A very key definition to remember. Why are we teaching you all these characteristics? We want you, when you go to the field, to be able to identify what hazards are. So should they lack these characteristics, then you can quickly see that this will not fall into my inventory of hazards. So we're going to be looking at all these 11 characteristics to enable us as safety practitioners to ensure that we can, once we go to the field or to any workplace, be able to identify all these characteristics and identify hazards correctly. All matter on Earth comes from three states. Namely, we've got solids, liquids, and gases. Science also adds plasma as a fourth state. It is seen as fluorescent light, for example. The three states are also seen as different phases in which particular material or matter can present itself or exist. Also, a solid can become a liquid. Water, example is water. A liquid can become a gas, which is vapor. The opposite can also occur. A gas can become a liquid or solid. All right, let's look at these three states of matter. We said it's solid, liquid, and gases, as depicted on this picture. Let's explain it, each state separately. The molecules in a solid are closely bound to one another by a molecular force. A solid holds its shape, and the volume of a solid are fixed by the shape of that solid. If you go back and we look at that first example, you can see there's a block inside a cube there. It's solid. That means it can hold its shapes. It's got fixed volume. So that's an example of what I'm referring to. Let's look at liquids. Liquids, the molecular forces in a liquid are weaker than in a solid. And a liquid will take the shape of its container if provided with a free surface in a gravitational field. If you pour water in a glass, that water is going to take the shape of that particular glass or that container. Regardless of the gravity, a liquid also has a fixed volume. The third state, gas. The molecular forces in a gas are weaker than both solids as well as liquids. A gas also fills the container, taking both the shape and the volume of that particular container. Second characteristics. We said hazards are governed by natural laws. All tangible objects in life are governed by physical laws, scientific laws, or better known as laws of nature. Physical laws govern all aspects of our physical world, have the following characteristics. They are true, meaning by definition, they have never been repeatable contradicting observation. They are universal, meaning that the laws appear to apply everywhere in the universe. They are simple, meaning they can typically be expressed in the terms of a single mathematical equation. All right, as we continue by the characteristics of the natural laws. Physical laws that govern all aspects of our physical world, also, they are obsolete, meaning nothing in the universe appears to affect or influence them. They are also omnipotent. Everything in the universe apparently must comply with them. The laws are generally conservative of quantity. Physical laws are often expression of existing symmetries. And lastly, the laws are irreversible in time. That's your second characteristic. Keep it in mind. Another one, symmetry. Symmetry implies that the laws of physics or the laws of nature do not change from one moment to the next, which means the laws are symmetric. They do not change. Crowell expresses that we say that a thing has symmetry when transforming does not change it. Consistency with symmetry is change and consistency. In physics, symmetry has been generalized to mean invariance, not changing, or staying the same. Water has got three forms. Symmetry implies balance in the physical world, according to Mr. Crowell. Volume of water into molecules has got three forms. Symmetry means the property of holding together and retaining shape. Very, very critical, very important. Symmetry makes it possible to predict the nature and the interactions of hazards. Also refer to our prescribed books, page 20, the rest of the paragraph, where it explains the importance of symmetry with health and safety. And I'll explain it in just summarize it for you. What it says that because we understand that hazards are symmetrical, and we have a specific machine in the workplace, meaning that we understand the nature and the content and the use of that particular machine. So it gives us the ability as health and safety practitioners to predict. If it's a grinding machine, we know that particular machine is going to be grinding or rotating in a 360 degree trying to crush something. By the mere fact that we understand that and we see that machine as a hazard, it gives us the ability to predict what can happen before it can happen. Meaning that we are able to make sure that we get the necessary guarding, or we can make the necessary controls, like ensuring that whoever is working on that particular machine, because we know it's symmetrical and we understand it's a solid and we understand its movement, its crushing, we can protect and ensure that whoever is working on that particular type of machine will conduct their duties safely. So symmetry is very important to assist us as health and safety practitioners to predict the nature of hazards and understand them correctly. These are just examples of what is symmetrical: butterfly wings, wings of a dove, patterns of a tile, as well as human beings. You can look at us and you can know that we're symmetrical as well. Another important characteristics that we need to take note of, it's weight versus mass. We said all hazards have weight. Mass versus weight, very, very important. Mass is a measurement of the amount of matter an object contains. Also, the mass of an object does not change if the object changes from one location. It does not change. If you move it from here to there, the mass will still remain the same because it's the amount of matter that is contained in that particular object. Mass is measured by comparing a known amount of matter to an unknown amount of matter. Weight, on the other hand. Weight is the measurement of the pull of gravity on an object. Therefore, the weight of an object could change when it changes from one location to the other. Then weight, to determine weight, we can measure it on a scale. A very important table, ladies and gentlemen. Please make sure that you understand it and you can differentiate between weight and mass. The characteristics of mass and weight may affect the safety risk created by a hazard. The characteristics of mass and weight may affect the safety risk created by a particular hazard. If you get a call within the plant and they say, somebody, a 20-ton brick has fell on a specific piece of equipment from a height. So immediately when you hear something like that as a safety practitioner, you understand by the use of your understanding of mass as well as weight to say, this is a heavy object, it fell from a distance of such much, then we can expect or predict that damage can be severe if it's on equipment. Never mind if it falls on people working around that particular area. So understanding of these characteristics give us an in-depth as to understanding the safety risk levels that every hazard possesses. All right. Although the mass of two objects may be similar, their weight may differ. Look at that picture. You can see one of those heavy vehicles and then a person with his bicycle and a scooter with the help of his friend trying to move. By default, what they are trying to imply here is that they might have the same mass, but the weight between that scooter and that guy transporting things we don't know where, we don't know whether it's allowed even in South African roads, which I don't think so, and that heavy vehicle. They imply that the mass could be the same, but definitely the weight is not the same between the two objects. All right. Another important characteristics, volume and size. Volume of a tangible object is a three-dimensional concept of how much space it occupies. One-dimensional object which aligns and two-dimensional object which can be squares are assigned 0 volume in a three-dimensional space. Volume also indicates the capacity, which implies an indication of how much space an object occupies. Capacity specifies how much an object can hold in terms of its volume, and also volume implies the dimensional space that an object occupies. Size. Size refers to how big or small an object is. It specifies in a particular 1 or 2 or 3 dimensional measurements of an object in terms of its length, width, as well as height. Now, what you see in front of you in terms of that picture, these are typical accidents that can happen in the mining areas. So what has been done over the years, because these accidents used to happen for over time, a person driving that big loader there on top, if they cannot see up to a certain distance. So one way that such accidents can be prevented, ladies and gents, is to make sure that there's a clear separation between movement of heavy vehicles and light vehicles within a specific area. The weight, big and small. Can you see how big that object is? Size implies the physical dimensions, proportions, magnitude or extent of an object. Right. Another key definition that we need to understand is density. Density is a physical property of matter. It can be defined in a qualitative manner as a measure of the relative of heaviness or thickness of an object with a constant volume. Density also implies quality or condition of being dense or solid. It refers to closeness or thickness of atoms as measured by the amount per unit size, or spatial property being crowded together, or the degree of compactness of an object. Synonyms to density are concentration, denseness, and compactness. As you can see in that particular picture, high density atoms are more solid, they are only closely compacted together. If it's got less density, then atoms are less spread out. That means it's not as solid. Density is a measure of mass per volume, per unit volume, a measure of how much material is in a given space. It is important to remember that solids are usually denser than fluids, which are usually denser than gases and vapors. If we go back to our definition of matter as a characteristics, we saw that in terms of compactness, in terms of atoms and matter, and in terms of volume, what was happening there. Generally, density can be changed by changing either the pressure or temperature to which a substance or object is exposed, totally denser than gases or vapors. The increase in temperature decreases the density, while the increase in pressure increases the density. Table 2, just an example of substances and their density numbers. Shapes. Shapes refer to the outline, contour, or form, embodiment of an object. A shape sets boundaries of a three-dimensional figure or hazard object traditionally indicated in the terms of length, width, and dimension or height. Physical objects come in all shapes and sizes. Like size and shape, like size, the shape of hazard and object can also have positive or negative effects on safety in a workplace. Typically, the shape of an object can be characterized by basic geometry, such as points, lines, curves, planes, and so on. And the picture there is just an example of the different shapes that you can find. Why is it important for us to understand this? So if you're working in a workplace or in a workshop, and you can see that people are using equipment or material with different shapes. If it's sharp enough, it's pointed, you can understand that people can get injured as a result of impact with that particular object or hazard. Then you can make sure that it does not happen. By having prior knowledge of shapes, it's going to help us as healthy practitioners to make the necessary controls to avoid accidents and incidents in the workplace. Surfaces or texture. Surfaces represent a two-dimensional area or manifold. Surface, also known as texture, refers to the outer or the topmost boundary or area of an object. Different types of surfaces: flat, smooth, rough, rippled, and so forth. Surfaces need to be considered when analyzing hazards and analyzing safety risk in the workplace. For example, if you're working in a kitchen, you will avoid slippery surfaces. or if it's unavoidable, you make sure that the proper personal protective equipment, the boots that they are wearing, they are rubber-soled so that you avoid slips, trips, and falls within that particular area. Energy. This is one of the key characteristics that a hazard will possess. This is one of the key characteristics that we need to understand, that when we're looking at safety risk levels, it is often the energies that those hazards contain that can lead to an accident or damage to property or degradation to the environment. Energy is quite important. Energy is a fundamental concept in physics with applications throughout the natural sciences. It is conventional to define energy as the capacity to do work. That's a conventional definition. But energy can be defined as the strength and the vitality required for sustained activity. We also have different forms of energies. Electrical energy, which is stored in a battery. The chemical energy stored in a portion of food, along with the oxygen needed to burn it. The thermal energy from a heater. The kinetic energy of a moving train or any moving object. And also the nuclear energy. Very important. We've got two forms of energies. Kinetic energies due to and in form of motion. Potential energy due to configuration, including, for example, gravitational, magnetic, chemical, electrical, and elastic energy. All the other energies that we may encounter on a daily basis are just manifestations of either potential energy or as well as kinetic energy. As long as it's in motion, then you know it's kinetic. But if it's just sitting there, it's potential energy waiting to be moved, then it's going to be converted to kinetic energy. Kinetic energy of an object is the extra energy due to motion, very important. Remember that all forms of energy can be categorized into two main classes: potential energy and kinetic energy. One form of energy can often be transformed into another form with the help of the device, which is also a hazard. Example, a dam transforms gravitational energy into kinetic energy of moving water when opening the sluice gate. So when water is within an enclosed area and it's closed, that is gravity holds it together on the bottom, it's your gravitational energy. But once the gates are opened, the water is going to flow. That means movement and motion is involved. It's going to be transformed into kinetic energy of moving water as a result of opening those sluice gates. So it is evident that it is possible to transform one type of energy or one form or one class of energy into the other. In safety management, very key, the term energy refers to the energy that is an inherent part and parcel of that particular hazard, or that can be created by hazard or hazards. Therefore, all hazards possess kinetic energy. However, not all hazards have kinetic energy in a sense that it can move from point A or B on its own. It needs to interact with another source. That's why we said it has both closing and collision properties, as we've seen from the definition of Mr. Fuller and Fassi. Thus, all hazards have mass and an inherent energy as the ability to do something. Therefore, all hazards are sources of energy. Very, very important. Hazards are sources of energy. In a true sense, it is the energy of the hazards that creates the safety risk in a given situation. Very important. It is the energy of the hazards that creates a safety risk in a given situation. All right, another characteristic, hazards pose safety risk and can create safety risk levels. All tangible objects, which are our hazards, have the potential to cause harm to humans or damage to property or the environment. All hazards have one or more forms of energy or potential energy. Humans use the energy of the hazards to achieve goals or objectives. A kettle boiling, meaning that your electric energy, and transporting of goods, meaning our kinetic energy, and so forth. Utilizing the energy of the hazards offers safety risk in some form or another. Safety risk related to an inherent characteristics of hazards are called inherent safety risks. They are part and parcel of that particular object, which is a hazard. The inherent safety risk level that a particular hazard possesses in any given situation is inseparable from such a specific hazard. It is the part and parcel of such hazards. Example, flame has heat. Once you have a flame, heat is going to be part and parcel of that particular hazard. Another important characteristics, interaction. Interactions or interface implies the reciprocal action or influence of one object upon the other or between two or more objects. In physics, an interaction specifically refers to the action, force, or influence of one physical object upon another. The transfer of energy can occur between elementary particles, and the field, or between the fields. Interactions. There are three levels of interactions, which are namely non-interactive, reactive, as well as interactive. Non-interactive implies when there is no interaction or influence between the two objects or between any hazards. There is no interaction at all. It's a remote and a remote here. They're just sitting there. They're not interacting. Reactive interaction implies when an object reacts to one object, even though it may be exposed to more than one object at the same time. Chemistry will be a big example of that. You're going to mix this, and it's going to combine with one element without combining with another one. Reactive, that means there's going to be some sort of a reaction, collision or mixing or integration of some particles, but in this case, it must react to one of the particles without necessarily reacting with another, even though it's exposed to one or more object at the same time. Interactive implies a reaction to a number of influences exerted implies a reaction to a number of influences exerted either by one or more than one object or hazard or multiple objects of hazard. Interactive implies a reaction to a number of influences exerted by either one or more than one object or hazard or multiple hazard. Now we looked at the levels. Now we're going to be looking at the types of interactions that can occur. There can be three types of interactions between objects, namely additive, synergistic, as well as antagonistic. Additive interactions means the effect of two hazards or objects totals the sum of the effect of the two objects taken separately. The additive interaction means the effect of two objects totals the sum of the effect of the two objects taken separately. So that means you're adding something on top of something. But when you look at differently, it's going to give you the same balance. Synergistic interaction occurs when the effect of two or more objects or hazards integrated together are greater than the total effect of the different objects. That means if you mix something, hydrogen with chlorine, together is going to form an hydrochloric acid, meaning hydrochloric acid is more potent or more dangerous than hydrogen and chlorine taken separately. It's synergistic. Antagonistic interaction means that the effect or the influence of one or more objects or hazards on another or other objects is less than the sum of the different objects taken separately. Meaning that you're going to dilute something which is more dangerous with something which is lighter. It's going to reduce the effect of that particular one. So that means the reaction is antagonistic. With synergistics, it makes something which is even more dangerous. If you take something dangerous with antagonistic, we mix it with something, it's going to make it less dangerous. Additive, synergistic, as well as antagonistic. The interactions of hazards and their energy exchange are of the significant importance to safety management in order to understand the nature and the interaction between hazards, the nature of the energy exchange, as well as the effect or the outcome of such interaction or interface that usually result from that energy exchange. Very important. For us to be able to understand the risk that the particular hazard possesses, we need that interaction as well as understanding the energies of that particular hazard. So be able to understand the safety risk levels of which that particular hazard possesses. Very key for us. For instance, water added to acid may dilute the concentration of the acid, reduces the hazardness of the acid, antagonistic interaction. On the other hand, adding water to chlorine generates a thermal energy which produces a different level of safety risk than water or chlorine. It can be more acidic. It's going to be even more dangerous. Synergistic interaction. This table just sums up what we have said. Additive, synergistic, and antagonistic types of interactions. These are called the types of interactions. We've already gone through them. Additive, the effect of two or more hazards totals the sum of the effect of the two objects taken separately. Synergistic, the effect of two or more hazards added together are greater than the total effect of the different objects or hazards taken together. And lastly, antagonistic, the effect of two or more hazards is less than the sum of the different objects taken separately or jointly. Very important. Interactions and the energies of hazards are key to us as safety practitioners. Human beings as unique kind of hazards. Believe it or not, a human being is a hazard. Two specific features of humans that need to be considered. Humans show common characteristics of hazards. We have matter, we have mass, we have main, we can interact, we have symmetry. We possess almost all 11 characteristics of those hazards, which qualifies us as human beings that we are truly hazards, but with our own uniqueness. Humans show common characteristics of hazards, but they also differ in having added characteristics like the psyche and the mind that other hazards do not have. Humans also show common characteristics of hazards. Tangible object duly possesses closing and collision potential energy. We also possess all 11 inherent characteristics of hazards as explained previously. Therefore, humans are hazards. Humans engage in interaction with hazards on a moment-to-moment basis in order to sustain life and to realize our objectives. And human beings need hazards to live. And we cannot live without hazards. Humans are therefore always exposed to the inherent safety risks that hazard poses. Now, it's very important, ladies and gents, when you get to the field, you often experience that your supervisors or people that are in the field already, they use the word hazard and risk interchangeably. And that's not so. Hazards are part and parcel of our daily life. You cannot say you want to remove all hazards in the workplace. No, it's not possible. Then you're going to have an empty workplace. But you can try and minimize or remove the risk associated with hazards in the workplace. Bear in mind. Unique properties of humans, we said we are different from other hazards because we have a psyche and a mind. And then let's look at those unique properties. We have a psyche and a mind. Human mind is not subject to the laws of nature. The human mind is not true, it's not omnipotent. Remember those characteristics that we looked at from laws of nature. Human behavior. Humans may choose to conduct themselves in the way they prefer in a given situation. A human behavior is governed by normative, society set standards. Human behavior is directed or governed by normality or oughtiness. Concept of norms, the way you live, the society that you engage in. However, human nature does not consistently comply with normality or oughtiness. Hence, we have prisons, we have laws, people breaking laws of oughtiness or normality, as we may say. Their thoughts and behaviors may differ even from one moment to another in an exact same position. Today you're feeling good, somebody teases you, you're not angry. Tomorrow, same situation, same place, somebody teases you, you are angry, you slap him. Humans have the ability to fluctuate in their mindset. That's why we change our minds momentarily from time to time. Examples of disregard of normality or oughtiness by human beings. Look at those two pictures, and everything is wrong. We don't know people are stealing cable there or trying to fix electricity, but they've got a cherry picker, and then inside the cherry picker, they put in a leather. Is this safe or not? Definitely it's not safe. Look at the second picture, a homemade geyser, if I may say so. It's got an Energate bottle there, water flowing straight to the kettle. Probably that kettle is on already, and what he expects there is hot water from the basin. And that's what humans can do. And it's disregard of normality. So what we have looked at in this particular chapter is all 11 inherent characteristics of hazards. For us to be able to identify hazards correctly, we need to understand each and every one of them so it can help us as health and safety practitioner to predict hazards correctly and to anticipate what can go wrong, the safety risk levels, should there be any of those interactions we spoke about, as well as understanding the energies which can create a safety risk. I thank you all.